I think this might be the world's smallest Bitcoin price tracker. I made it using an ESP32 and a few other components. Let's put it together. First, let's open this 0.96-inch OLED display. It has 128 by 64 pixels and it costs less than $2 US. This one has yellow pixels in the top section and blue for everything else. It makes it look like a multicolor display when it's actually just a single color output. It has all the drivers and electronics on board, so there's only 4 connections using the I2C serial bus protocol. Next, let's look at the ExpressIF ESP32 microcontroller. I bought a bunch of these for about $2.40 each. It has all the features of this development board, but it's just the microcontroller all by itself. Now the full-size development board is just that, for product development. And it confuses me sometimes when I see finished products shipped to market with this full development board inside. It has an onboard Wi-Fi antenna, pinout connections, voltage regulator, and a USB connector, and all the other LEDs and buttons you need for development. In this project, though, I'm just going to connect to the microcontroller itself. On the back, you'll see all of the same pins from the development board. Today, we will only need to connect to a few pins. We will supply 3.3 volts DC here. This is the enable pin. We'll pull it high by soldering it to the input voltage pin. I/O number 22 is the SCL pin for the I2C bus. It's also called SCK, and that's the clock signal for communications. TX00 is for serial transmit. RX00 is for serial receive. We're going to use these 2 serial pins to upload our Arduino program to the chip. I/O number 21 is the SDA pin for the I2C bus. It's the data signal. And finally, I/O0 is the boot pin. We'll pull this low and then upload our code and then we'll let it float during normal operations. Lastly, there's the ground pad. There are a few ground connections on the edges, but this is the easiest one to solder to. On the front, there's a connector for an external Wi-Fi antenna. My internet router is pretty close to my desk, so I'll try it without an antenna. The ESP32 runs at 3.3 volts. However, USB power is 5 volts and it would damage the chip if we connected it to it directly. So we'll add this 3.3 volt regulator to the project. This one can handle 500 milliamps. It has 2 ground pins, an input voltage pin, and an output voltage pin. These are standard DuPont jumpers like you might use on a breadboard. Female on one end and male on the other. We'll solder these directly to the chip. And here is a USB charging cable. We'll cut off the end and we'll use it to power just the components. This project needs a case. Instead of 3D printing a box, let's just make an origami enclosure out of paper. There's a link to this pattern in the video description. To make the USB power supply, just cut off the end from an old charging cable. And strip back the cable to the wires inside. We only need the power wires, usually red and black. So let's get rid of the other 2. Great. Now we have a reliable 5-volt DC power supply. Now let's cut our wires to size. The colors and the end types are shown in the schematic linked in the video description. Now I can start soldering. We'll solder the wires to the voltage regulator first. An extra set of hands makes things much easier. It's not pretty, but I can see that nothing is touching. The pinout connections on the ESP32 are pretty small. It's meant to be soldered to the surface of a printed circuit board. This will be pretty challenging to solder, but let's give it a try. To make things easier, let's make a jig using a block of wood and a rubber band to hold all the wires. I'll insert the wires one by one. Now we'll use double-face tape to hold the chip against the wires. And let's tape this jig to a nice sturdy base. And let's start soldering. Add just enough heat to let the solder flow. It's not very pretty, but it doesn't have to be. We just need good connections. Now we solder the power supply I made earlier to the ground pad. And we'll connect the 3.3 volts from the power supply to the input voltage pin and the enable pin. It's worth checking for accidental connections with a multimeter. Now I've connected the display and everything is assembled. To upload the code, I'll use this USB programmer, which I'll use to send and receive serial data to the microcontroller chip through the receive and the transmit pins. Transmit on the programmer goes to receive on the chip. Before programming, we need to set the boot mode of the chip by connecting pin I0 to ground. Boot mode will be set once we power up the chip. I've powered both the chip and the programmer from my laptop. Let's open Device Manager and check which port the TTL serial port is on. Mine is connected to COM4. I'll open up the Arduino IDE. And under Preferences, let's add the URL for the ESP32 core. There's no ESP32, so I'll open Board Manager and search for ESP32 and install the ESP32 board by Espressif Systems. Now when we go back to Board Manager, we see all of the ESP32 boards. We will use ESP32 Dev module. I'll leave all of the default settings and I'll just double check that I have the right COM port. Now let's paste the code I've written. I use a few special libraries that you'll need to install, like Wi-Fi, HTTP client, and the Adafruit display drivers. You can download my code from the link in the video description. I'm not going to explain in detail the Arduino code, but it basically connects to my Wi-Fi network, sends an HTTP request to the API at coindesk.com, receives an HTTP response with the current Bitcoin price, and then it formats and updates the Bitcoin price on the display every 10 seconds. Now let's get ready to upload our code to the chip. I'll make sure that these two wires are connected, which joins pin IO0 to ground. And then I'll power off and on the chip so that it accepts the boot mode. Now we can upload. Oops, it's asking me to save first. And let's expand our console so we can see what happens. After compiling, it starts uploading to the chip. And it was successful. Now let's take it out of boot mode so we can try using the code that we've uploaded. We'll power cycle the chip. And it's connecting to my Wi-Fi. It shows the IP address, and it starts displaying the real-time price of Bitcoin in US dollars. Now I'll disconnect the programming connections. And I'll try running it from just a USB power supply. Again, it works great. To build the case, first you'll need to download this pattern from the link in the video description and print it out on some construction paper. I'll cut out the pattern with a hobby knife. Now just fold along the dotted lines. And just snap it together. It looks pretty good. So now I'll just jam all the components and the wires inside and close it back up. And it's done. Let's try out the finished product. Perfect. I hope I've been able to show you the power of the ESP32 microcontroller in this simple example. You can still get all of the performance of the chip by itself without the size and extra expense of the full development board. Thanks for watching.